Now in the last part of the question then we've got to justify that the volume that we found was a maximum. And to do that there's a couple of ways that spring to mind. The easiest I feel is to just work out the second differential, that is d2v by dr squared. Put our value of r in that we found as being 6.5147 and check the sign. If it comes out as negative, then it is a maximum. And that's the method I'm going to show you first of all. So therefore, if we differentiate this again with respect to r, we get d squared v by dr squared is going to equal, well, that term's going to disappear, and then if we differentiate this we'll get minus 3 times the 2, which is minus 6 pi, and then reduce the power of r by 1 and you just get minus 6 pi r. So we can see that when r equals the value that we found in the previous part to be 6.5147 and so on, if we substitute this into here we can say that therefore d2v by dr squared is going to be minus 6 times pi times 6.5147 and so on. There's actually no need to work this out because clearly this is going to be a minus value, so we can see that this is going to be less than 0. And so if it's less than 0 we know that this is a maximum. So therefore we can say that v is a max. Okay? Now I did say that there was another way that you could do this. I'll show you what that is. You can do it via a table if you like, and what we would have is the radius r. We've got that r equals 6.5147 and so on, and we would take two values to the left of this and to the right of it, fairly close. So we could take, for instance, r equaling 6 and say r equaling 7, and then we would look at the gradient function, in this case dv dr, and we know that when we put this through here we get 0, which means as far as the slope of the graph goes, let's just write here slope, we know that the graph would be horizontal. Okay, the tangent would be horizontal. If we were to put 6 into this equation, I'll leave it up to you to do that, but what happens is that you get a positive value. This is positive. Alright? And positive means that the slope is going upwards. If you put 7 now through dv dr, what you'll find is that you end up with a negative number. So just write here that you get a negative number, and that means that the slope of the tangent at that point would be downwards. So can you see that our curve would have a maximum? So this is an alternative way to showing this. So you could just again say that therefore v is a max. Okay, well that brings us now to the end of this question.